Ni kau dah apa? Dah Zoom eh? Apa?
Okay, start.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today our group will be present a topic that is in mathematical chemistry, that is stationary points and partial differentiations. Before we start our let me introduce our members first. Okay. Me, Daniel bin Editan, and 4 other members, that is Muhammad Syukur bin Ilyas, Amirul Aiman bin Abdullah, Muhammad Nakib bin Muhammad Ruslan, and Amir Faisal bin Zulkarnain. So let me pass to our first presenter, that is Muhammad Nakib bin Muhammad Ruslan.
Okay, Bismillahirrahmanirrahim. Thank you, Daniel. Okay, so I will present to you about the type of stationary point, which is there are 3 types of stationary point. Which is stationary points occur when we have dy over dx equal to 0. This represents when the gradient of a curve is horizontal. We have 3 types of stationary points. So the first type of stationary point is local maximum. We can see that when we pass through a maximum at the gradient goes from being positive to being negative. So the example has been given on the slide. So next, okay, the second type of stationary point is local minimum. So we can see that when we pass through a minimum, the gradient goes from being negative to being positive. So as we can see from the example, the gradient is from being negative to positive. Okay, so the next slide. Okay, and the last but not least, the third type of stationary point is point of inflection, which is the final type. Finally, when we pass through point of inflection, we should note that the gradient remains of the same sign, which is so either positive both sides or negative both sides. So I pass to the next presenter, which is Aiman.
Okay, kita akan teruskan dengan classifying stationary point. So dia ada 2 cara, iaitu first test dengan second test. So first test ni kita akan gunakan second derivative. Lepas tu kalau kita dapat nilai dia lebih besar daripada kosong, dia adalah minimum. Dia ada point dia adalah minimum. Kalau dia dapat lebih kecil daripada kosong, so nilai dia adalah maksimum. Tapi bila dia dapat sama dengan kosong, kita akan gunakan second test, iaitu kita akan guna first derivative tu. Contoh nilai dia kosong kan. So kita akan ambil nilai negatif 0.5 dengan 0.5, iaitu satu di belah kiri dia dengan satu di belah kanan dia. Masukkan dekat function tu. Dan kita akan tengok kalau jawapan dia function tu, kalau kita ambil nilai x tu left lebih besar daripada kosong, x right tu lebih kecil daripada kosong, kita akan dapat maksimum. Kalau left tu lebih kecil daripada kosong, right besar daripada kosong, dapat minimum. Tapi bila simbol dua-dua sama ada lebih besar, dua-dua lebih besar atau dua-dua lebih kecil, benda tu akan jadi inflation. So kita akan terus tengok kepada contoh untuk first test ni. So soalan dia, classify stationary point of y sama dengan x kuasa 4/4 tolak x kuasa 2/2. So first kita buat derivative dia dulu. Akan dapat x kuasa 3 tolak x. So kita kembangkan, kita akan cari nilai x tu. So kita dapat nilai x tu sama dengan 0, 1 dan negatif 1. So dia ada 3 nilai kat situ. So kita boleh pakai first test sebab dia bukan nilai sama dengan 0 sahaja. So kita buat second derivative dekat yang nilai pertama tu, kita akan dapat 3x kuasa 2 tolak 1. So kita masukkan nilai 0, 1 dan negatif 1 tu dekat second derivative ni. Dan nilai yang kita dapat tu akan menentukan point dia adalah maksimum, minimum Maksimum atau minimum. Okay. Untuk yang contoh untuk second test ni, tengok soalan yang seterusnya, slide seterusnya. Okay. Soalan dia, Y sama dengan X kuasa 3. So kita first derive dia dapat 3X kuasa 2. So X tu sama dengan kosong saja, dah tak ada nilai lain kan. So kat sini kita tengok tak boleh, bila kita masukkan dekat second derivative tu, nilai dia akan memang jadi kosong sahaja. So kita tak boleh nak buat first test ni tak valid. So kita kenalah guna second test. So second test ni, okay, kita dah dapat nilai dia tu kosong kan. Masukkan nilai kosong tu dapat jadi kosong. So kita kena ambil nilai yang terdekat di kiri dan kanan. Maksudnya kalau kat graf tu kosong sebelah dia negatif 0.5, sebelah dia 0.5 kanan. So masukkan dekat function yang pertama 3x kuasa 2 tu. Sebab tengok formula tu, function pertama, derivative yang pertama masuk kat situ. So tengok formula, kau akan dapat jawapan dia macam mana. So ikut soalan ni jawapannya dua-dua simbol sama, lebih besar daripada kosong. So graf dia adalah inflation stationary point. So kita akan teruskan kepada seterusnya iaitu syukur.
Okay, thank you. So we will go on to partial differentiation. It's same as partial derivative. A partial derivative is a derivative where we hold some variable constant. Like in this example, as you can see the right on your screen, a function for a surface that depend on two variables which are x and y. When we find the slope in the x direction, we have found a partial derivative, or we can find the slope in the y direction. Next slide. Here is a function of one variable, such as fx equal to x to the power of 2. And its derivative by using the power of rule, it will be f prime x equal to 2x. But what about a function of two variables, which are x and y? fxy equal to x to the power of 2 plus y to the power of 3. To find its partial derivative with respect to x, we treat y as a constant. Imagine y is a number. For the explanation to the words before, first the derivative of x to the power of 2 with respect to x is 2x. After that, we treat y as a constant. So y to the power of 3 is also a constant. Imagine y equal to 7. Then 7 to the power of 3 will be 343. Is also a constant. And the derivative of a constant is 0. Next slide. To find the partial derivative with respect to y, we treat x as a constant. F prime y equal to 0 plus 3y to the power of 2 equal to 3y equal to 2. 3y to the power of 2. The explanation is we now treat x as a constant. So x to the power of 2 is also a constant, and the derivative of a constant is 0. The derivative of y to the power of 3 with respect to y is 3y to the power of 2. That is all there is to it. Just remember to treat all other variables as if they are constant. So for the next example, at the next slide, the question is f x y equal to y to the power of 3 sin x plus x to the power of 2 tan y. It has x, and as you can see, it has x and y all over the place. So let us try the letter change trick. With respect to x, we can change y to k. So fxy equal to k the power of 3 sin x plus x the power of 2 tan k. After we change from y to k, the result will be f prime x equal to k the power of 3 cos x plus 2x tan k. But remember to turn it back again. And it will be f prime x equal to y the power of 3 cos x plus 2x tan y. Likewise, with respect to y, we turn the x into a k. Like f xy equal to y the power of 3 sin k plus k the power of 2 tan y. And the result will be f prime y equal to 3y the power of 2 sin k plus k the power of 2 sec the power of 2y. And if we continue, the last result will be f prime y equal to 3y the power of 2 sin x plus x the power of 2 sec the power of 2y. If you can see, it just change the k to x. So it say as only the radius change by the tiniest amount. But only do this if you have trouble remembering, as it is a little extra work. So the next presenter will be Amir Faisal. Continue the rest.
Okay, thank you, Shuko. Okay, so we move on to three or more variable. As we know, variable can be x, can be y, can be z. So what happen if we combine it with three? We can have three or more variable. Just find the partial derivative of each variable in turn while treating all the variable as constant, such as this. The volume of cube with a square prism cut out from it. As we can see here, z, 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 x, x, y. Given f x, y, z equal z square minus x square, Allah, z cube minus x square y. Find f prime for each variable. Okay, to find the f prime x or derivative of x, we made the other variable that are not connected to constant, such as z power of 3, but when we derive it, it becomes 0 because we still consider it as constant. So the derivative of constant is 0. Minus 2xy because the power go to the front, so it becomes 2xy because the power, the square, minus 1 equal power of 1. The y is considered as the variable because they are attached. Okay, so the answer is negative 2xy. Okay, Allah. Okay, for the f prime y, 0 minus x square, we still, the z we consider as constant, so it still becomes 0, minus x power of 2. So the answer is negative x power of 2 because we want to derive y. So y is power of 1. We brought the power to the front and it become 1x square. The x we do not derive because we just want to derive the y. So the answer is negative x square. For the z part, f prime z equal to 3z square minus 0 because the xy does not include, we assume them as constant. We just derive this thing. So from the z cube, the power brought to the front, that will become 3. The power, the power square, the power cube minus by 1. So it become 3z square. So thank you for listening. That's all from us. Thank you.